Today we built the second version of the hand. This is the original one. Both are right hand, so palm facing up and palm facing up. There are several reasons that we wanted to get the second hand. The first one is the design. So each finger is connected to a single motor here, and then when you move the motor, you can move the finger like this. But since this is a palm, if something moves on your palm and you grab the finger, that'll be weird. When you grab an object, for example, if you grab this and you grab it on your hand, but imagine there's something between the object and your palm, right? It will be difficult to grab the object reliably. On the other hand, here, all the motors are behind, on the back of your hand, here. So the palm is very clean, so clean and clear. So when you grab object, there's nothing moving between the palm and the object. So that's good. The second thing is we often need this motion of the fingers, right? Let me grab that object. This one. Imagine we want to spray this one. Then what we do is like this. And as you can already see, my fingers have this motion. But then the first version of the hand don't have such flexibility because it has only single motor, which means 1 degree of freedom for each finger, only doing open and close motion. On the other hand, this guy can do this, right? So this has 4 motors on each finger. 1, 2, 3, 4, right? So you can do this. There will be this motion. You can do this. It's this motion. This is of course open it, and the whole finger can move, right? So it's this motion. So it mimics the human motion. So this finger is more flexible, and there are 4 fingers, 4 motors each, means 16 motors in total, and 16 degrees of freedom. So it's a quite flexible finger. But there's one drawback, is that this hand is quite big and heavy, because we have all the motors in fingers, which means, the end effector, basically this gripper, is heavy. On the other hand, if you use tendon-driven approach, that's kind of popular these days. All the motors, you can move it to your wrist or forearm, so that you can save some weight. But I think we wanted to explore the flexibility of the hand first, so we can sacrifice weight a little bit. Okay, so we haven't wired these hand motors yet, and we also need to calibrate them and find a way to control them. That's gonna be the job for tomorrow. So that's it for today.